Take it away, Sam.
All right, yeah, so I won't bother going through the abstract because we're going to get right into the presentation. But I titled this Getting Quicker Feedback and Getting Started with Continuous Integration. So we're going to talk a little bit about that. Oh, wow, that went real fast. Before we get started, Alan mentioned GDevCon NA. So that's in Boulder. It's October 20th and 21st. And you can get tickets up until October 5th. So there is a discount too. So if you bring a bunch of people, so there's a group discount. Yeah, and we have a whole bunch of sponsors, and you can go to our website and check that out. If anybody has any questions, you can just ask me about that later, or send me an email or something.
Yeah, there should be time after your presentation is done, Sam, if anybody wants to ask us about GDevCon NA. NA does not stand for not applicable. It stands for North America.
That's a good distinction, Alan. All right, so as Al mentioned, I run my own business. It's called SAS Workshops. Our goal is to help LabVIEW teams perform at their best. So my theory is that we all start out as something other than programmers. So we're all scientists, engineers, etc. And I feel like we miss out on a lot of the things that people in other programming languages and other disciplines have figured out. So my goal is to try to teach LabVIEW programmers how to do some of these things that other programmers in other languages do. So, and one of those things is continuous integration. So, continuous integration is kind of this weird term because depending on who you talk to, it means different things. The classical idea behind continuous integration has to do with integrating everybody's changes together often. And so that means merging in source code control terms, which can be a pain. So if you look at the top diagram, right, we have this main line that is our repo, and then Scarlet and Violet are both doing some work in parallel. Right? And this could be separate branches. This could be their own local copies of the repository. And they've each made some changes. And at some point, Scarlet pulls in the changes from the main line, and she has to integrate those changes with her changes. OK. And Violet does the same thing. And then at that point, it's kind of a race to see who can make changes and integrate them back into the main line. Right? So Scarlet makes a few more commits and commits them back into the main line. And the reason it's a race is because she wants to get there first, because her merge is really simple, right? Because she's only taken what's already there and added onto it. So that's really easy. Versus when Violet goes to merge her changes, she ends up with this big, huge merge commit because she's got to merge all her changes with all of Scarlet's changes and any of the other changes to the main line. Right? And so that's what those yellow stop sign looking things represent. Right? And you notice the last one's really big. And so continuous integration, the idea is to reduce the time between when we merge and to make those merges really small. So instead of having one big merge at the end, we're going to have one small merge, or we're going to have multiple small merges. So if you look at the bottom graph, right, everybody's constantly pushing and pulling changes from the main line, and you notice there's a lot more yellow dots, but they're all really small and really simple because you're only integrating one or two commits. And so that's kind of the classical idea, is to reduce the size of these big, huge merge commits. And when you do that, part of the point is to make that merge commit and then verify that things actually work. So that typically means that after you make the merge commit, you run some tests, you run your build to make sure that you didn't break anything. And so that's kind of led to our modern understanding of continuous integration, which is a lot of people associate continuous integration with this automatically running tests and builds. And so they associate with GitLab or Jenkins or Travis CI or Circle CI or one of these tools. And so depending on the context, somebody might say CI and they might mean two completely different things. Because if you pay attention to traditional CI, right, if your goal is to merge often, you wouldn't create this big feature branch and wait 3 or 4 days and then have a pull request process that takes another 2 days before you merge everything back in. But you can do that, and you can use GitLab CI or Jenkins to run a whole bunch of tests on that. And some people call that continuous integration. And I don't really care what you call it, but it's just a different thing, right? So I'm not mad about like people misusing the term or whatever, but just when somebody says continuous integration, you kind of got to clarify, do they mean automating a bunch of stuff or do they mean integrating your changes frequently? And there's a reason to integrate your changes frequently. So one of the things I try to focus on a lot lately in my development is trying to get rapid feedback. So taking really small steps and then immediately finding out if it worked or not. And so here we have a repository and we have a commit that we know works and we've tested it. And we're gonna get some weird feedback. Good. That appears to have gone away now. Cool. Thank you to whoever muted themselves. So we have version 1.0 that we have tested and we know it works. And by the way, if anybody has questions, you can totally, I don't know what the best way to handle that is, Alan, but you can either throw them in the chat and Alan will interrupt me, or you guys can interrupt me or whatever. So we have version 1.0, we know it works because we've tested it, we've sent it out to our customers, everything's good. And then we make a bunch of commits, and maybe we make a dozen commits. And all of a sudden we decide, well, we're getting ready for next release, so we'll run our test suite again, or we'll run our build process, and we realize that it's broken, right? But the question is, where in this whole chain of commits did it actually break, right? Because the problem might not be our last commit, it could be one of the earlier commits that introduced our problem. We just don't know. And so there is a solution to this problem, and that is you basically go back through the history and you figure out which commit introduced the problem. And there's a tool to do that built into Git called Git bisect. And if you've never used it, you should probably go and learn how to use it because it is useful when you do need it. Hopefully you don't need it very often, but basically what it does is you tell it which commit's good and which commit's bad. So in the case of the previous one, you would tell it that v1.0 is good and the commit we're on is bad. And it would go out here to the middle and it would pick this middle commit. And then it would ask you, is it good or bad? And then it would split the search space in half. So it's like a binary search. And then it would add, and then it would ask you here, is that one good or bad? And eventually you come up with the right answer. So you can do that. And then let's say you figure out that it was some commit, say 6 commits ago, right? And that one commit, before that commit, everything was good and all your tests passed and everything built. And after that commit, things stopped working. So you could just go and you do a command in Git called git revert. And that's supposed to introduce a change that is the exact opposite of whatever that commit is. And you could try that. With LabVIEW, you're almost guaranteed to get a merge conflict. So now you've got this big, huge merge conflict to sort out. It's kind of a pain, right? So you can solve that problem, but it's painful. But if you have rapid feedback, the problem gets way simpler. So I have my version 1.0. I ran my tests, I built it, I released it, everything's good. Then I make another commit and I run the test again and I build it, everything's good. I do it again, everything works, I do it again. And then at some point I make a commit and I run the test and the test fail, right? Now at that point, I could go through all this debugging and figure out what's wrong, but the problem is really simple. I can just do a git reset or a git revert or a git reset or a git restore, and I can just throw away that commit or throw away those changes and go right back to a good state. So in my development anymore, I very rarely do any debugging unless like a customer brings me a problem or something. But like when my tests fail, usually it's like one commit. And so I just go and roll back that commit and go try again. Sometimes I'll look and see if there's something obvious like a typo or something, then okay, I fix that. And then I run the test and everything's good. But if it takes me more than like 30 seconds to figure out what's wrong, I just start over. And it's really, I find it quite amazing. So that's one of the reasons to take small steps, because then you can throw that stuff away and you don't care. Because if you're throwing away 5 minutes worth of work, you can recreate that a lot quicker and it's not really a big deal. Any questions so far?
Yeah, just on git bisect. It seems like you can really easily just check out whatever branch you want. What does bisect do above just if I wanted to manually check out branches and do my own kind of like binary search? Is there like a lot of benefit?
You could do it yourself. If you can write a script that runs the test for you and outputs a 1 or a 0, you can just feed it that script and it will check them out and run the script for you. So that's
Okay.
actually really good. You can't always do that.
Yeah.
Right. But if
And
it's something that like, the unit tests were passing and now they're failing, you can run that programmatically and output a 1 or a 0.
Okay.
And it'll resolve it in like 30 seconds.
Yeah, it does seem if you had that script, you might as well be running that before the commit anyways.
Yes. Yeah. Well, sometimes you can write the test afterwards, or maybe
true,
like a customer points out a bug and you're like, oh, I can write a test to find it. So if you
Mm.
can write a script that will find the bug and output 1 or 0, this is like super easy to do.
Oh, okay. That
but-
makes sense.
but
So you can
yeah.
kind of like post hoc
Yep.
develop a test and then manually kind of test your way through that. That's cool.
Yeah. Yeah, it is really cool and powerful, and it's pretty cool. So where was I? All right. So aside from taking small steps and getting quick feedback, another mantra that I like is start with the simplest thing that might work. Right. So what's the easiest way to get feedback on if you broke something or not? And there's really two really simple things that we can do. And one is write some unit tests. So unit tests, if you're not doing it, don't be intimidated. They're not as hard as they look. They're a lot simpler than people make them out to be. It's basically you just drop the VI that you're testing inside another VI. You wire some constants for the input, and you wire an equals, and you compare the output, and it just says, did I get what I expected or not? That's unit testing in a nutshell. Gets a little bit more complicated, but not much. And then the other thing you can do is build your application, right? So building your app, because unit testing will find logic problems. Building your application will find things like missing dependencies and weird things like that, and things that will cause your project not to build. And if you just have an exe and you're just building an exe, then you might be able to get away with just right-clicking on your build in your application project and just building it. But if you've got to build, an application and a couple installers and some other stuff, there's an application builder API, and you can write a VI that does whatever you need to do there that will build all of them in the correct order and do things like that. And if you're working with PPLs, there's tools for that. I think MGI Solution Explorer, and there's another one, Jovian Arts or something on GitHub has another one. I forget what that's called. LiveView Builder or something. Okay, so let's look at some demo code and take a look at this. So I had this kata that I put together. So kata is like an exercise that you do just to like practice writing tests and doing TDD. And there's a whole bunch of them. If you go look it up, there's a ton of them. One of them is the Yahtzee kata. And so I wrote one in LabVIEW. So for the TDD katas, it's just like a problem statement, and you use TDD to develop the solution. But this one is actually a refactoring kata, and so you need some starting code. So I have this repository here. You can write this down, gitlab.com, sas-blog/Yahtzee-kata. And it is some of the worst written LabVIEW code I've ever written. It hurt to actually write it, and it was actually quite hard to write it and be that bad. But you can go and clone this. And if we clone this, it's got a bunch of unit tests, so that's fine. So I've cloned this. So if I open this up, why is that open? That shouldn't be open. Oops. Don't need that. Right, so here's our project. These are all the VIs. Just to give you an idea how ugly the code is, take a look. That's actually one of the more mild ones. But you can open it up and you can click one button and it will run all the tests for you. And it takes a few seconds because VI tester is kind of slow. But now I know that the project works. And if I make a change that causes something to fail, as an example, let's say I change this. Right, so here's this code for a straight, and let's just say I go and make this case true. So I swapped those two. Right. And now I run, it should fail. Right. That means that my test coverage is pretty good. So if you ever want to look at how good your test coverage is, you can just go in your code and start changing things. And if you change something and the test doesn't fail, that means obviously that thing's not being covered by your tests. But okay, so I made some changes. It didn't work out. I can just go into Git here. If I type in Git status, you'll see. Oh, because I didn't save the VI. Maybe save. Now if I type in Git status, it should show me that that thing was modified. Right. So I made a change. I ran my test. It didn't work. I can just do git restore dot, and that will throw away all my changes. And I'm right back where I was. Now, one thing you'll note is I did not exit LabVIEW. So you have to exit LabVIEW before you do that, because that messes things up if you don't. So now let's just do this again. Because if you change it on disk and Git and you got LabVIEW open, it causes problems. So I wish that was better, but so now I can open my project and it's reset everything, and it should just test should all pass again. Let me show you that. So let's run the test again. And so that's pretty quick and easy to just throw stuff away. So I found before I was doing TDD, I would spend a ton of time debugging all kinds of stuff. And now it just seems to work very quickly and easily. And like I said, if it doesn't work, I just throw it away. I find it's very efficient. All right. Cool. I think I hit all those points. So the next step is, okay, I have to remember before I commit or whatever to click on that button and run the test, right? Maybe I forget or something like that. So how can I do this automatically? And the first step to doing all this stuff automatically is to be able to call LabVIEW code, call code to run your tests and do your builds from the command line. Because all the tools, all the CI tools and the Git hooks that we're going to talk about, they all work from the command line. And so you can automate anything that you can do from the command line. So in LabVIEW, calling LabVIEW from the command line, you can type in labview.exe and pass it a VI, and the VI will run. But the problem is it's hard to get feedback. It's hard for that VI to then write back to the command line, which is what you need for these tools, because you have to output either a 1 or a 0 to tell it that whatever you did succeeded or failed. And so there is a built-in LabVIEW CLI tool, but it pretty much sucks. Sorry if anybody worked on that here. I mean, it's not terrible, but James McNally has this GCLI that's way better. You can install it from VIPM, and it's got its own palette here. All these green VIs are for writing to the command line, and these blue VIs are for parsing options, for passing parameters back and forth. But basically, we'll look at this in a minute. Starting the CLI interface, you run that at the beginning of your VI, and that connects to the CLI, so you can send data to it. You can write a line, you can write a string, and you can send various exit codes. And then there's a way, if they pass you a path as a parameter, you can turn it into an absolute path. There's some tools for that. We're going to take a look at that in a second. Cool. So let's see. Do I already have that open? Yeah, cool. All right. So to use GCLI, you just type in g-cli, and we'll do help. And that gives you a bunch of options. So you can specify what version of LabVIEW you want to open. You can specify a bunch of stuff. You can specify use 64-bit. You can give it a timeout. There's a bunch of stuff there that you can do. There is a built-in test. So you can type in GCLI. Echo. echo. So the first part here, GCLI, this specifies the echo specifies the VI to run. We'll see that in a second. And then this dash dash is a separator, and everything after that are parameters that get passed to the VI. So we're going to pass it hello world, and it should echo it back out to the screen. So you'll see LabVIEW open up, calls this echo VI, echoes hello world back out to the CLI, and it's done. And he leaves it open so that it's easy for you to take a look and see what he's doing. So here he calls the start, and this outputs the parameters. He turns it into a spreadsheet string and sends it right back out, and then closes the connection, and then exits. Waits a second and then exits. So that's about as simple as it gets. In between opening up the connection and closing the connection, you can do all kinds of stuff. Anything you can do in LabVIEW, you can do within that VI. And you can easily create your own VIs that do all this using the GCLI API. Questions? Do you have another demo here? So in my project, I have this. Yes.
So Sam, you
yes.
run. So all right. So I haven't worked with GCLI before. You download and install it, and it's available from the command line, or you're calling it from a particular directory, or how does that work?
So if you install it, it should generally be available from the command line. I'm using git bash. So if you use PowerShell, I'm pretty sure it goes in the Windows path just fine. If you're using git bash, you may have to add it to the bash path. So there's if you Google how to do that, it's very easy. You set like a bash RC file as your profile, and you put in there a thing that just says add this directory to the path. And
I'm an old LabVIEW guy. That means what you just said means nothing to me.
Okay, cool. So it resides right here. Program files, GCLI, GCLI.exe.
Okay.
That's the first thing. So if you don't want to type out the whole path, right, you could type out the whole path, but Windows has its path variable, right? So if you go to, what is it, environment variables, edit the system environment variables, you can add it to your path. Okay. And so if you edit this, it should show up in there somewhere.
Okay, and that's just paths that'll go looking for an exe, and then you're good to go. Okay.
All right. And there's a way to do that for git bash too. So if I do this, do that in git bash, you just do this, and this is all very complicated, but there's like one line that actually matters somewhere. Maybe I don't have it in here. Sorry, we're going on a detour.
Well, you can move on, and we can take this offline if you want.
Yep. No, but yeah. So basically, yeah, if you type in G-CLI and it doesn't find it, it's because it's not in your path, and you need to figure out how to fix that. Okay. So here's my project. In my project directory. Oops, did I close that? Let's go back to the Yahtzee kata. So I have this GCLI directory. I have a test. So let's open this up and take a look at this. So this is going to run that test. So here we go. The heart of this is a little ugly. I apologize. I just hit block diagram cleanup. But the heart of it is this right here. This is the VI tester API. And what we're going to do is we're going to pass it the project path and a path to where we're putting the reports. And it's going to run all the tests. And then it outputs if we passed or failed. And it gives us some details. And then here we're taking a timestamp before we start. And at the end, we take a timestamp and we write out how long the test took. This is handling the error. So if there's an error, we're going to pass out the error code. If not, we're going to pass out a 0 if the test passed, a -1 if it fails. And we're going to pass out where the report's located at. And we're going to pass out the result as text and write that back out. Hopefully that's clear. I apologize. I should have cleaned that up a little bit more. But so I'll just close that. And now we can run that. using GCLI. Let me make sure I get the command right. So GCLI. GCLI /test. So even though you're in Linux here and you get bash, you pass Windows paths. So it's a /. And that should find my VI and run it. And I'm not passing any parameters or anything. I'm just running the VI. And so you see it says starting VI tester, tells it it passed, and it generated a report and ran it in less than a second. So, and we can go look at the report. And there you can see it ran all the tests. I don't know why it wants to open it in Internet Explorer, but that's what it does. So here's all the tests, and they all pass. So that's the first step to automating anything. So the first step to automating anything is figuring out how to do it in LabVIEW, right? So you can just run a VI and do it. And then the next step is being able to call it from the command line. And here you can then put it inside a script. And so this is getting a little bit more complicated. This is perhaps not the best example script because I borrowed it from another project and it's got a bunch of stuff that maybe it doesn't have to have in here for the example. But if you've never written a bash script, you just create a text file. Oops. Create a text file, name it something.sh. And this first line you have to have, and that's what tells it that it's a bash script. And then the hash marks are comments. This set EEO pipe failed. That's like some debugging thing. We're setting a bunch of constants. And here we're calling GCLI on line 15. Now, this die function is kind of important. When the script exits, if it fails, you need to make sure that the script passes out a 1 to the calling code so that it knows that it failed. And without this die function, sometimes that happens, sometimes it does. It's kind of dicey. So what I have here is in the GCLI line. Why do I keep doing that? Right, I'm passing it the LabVIEW version, right? So in the GCLI, there were some parameters you could pass. I'm passing a LabVIEW version and a timeout. I'm calling my test VI. And then these two bars mean if it fails, call this die function. And that just basically stops running the script and jumps to this die function, which just echoes out to the screen. It says it failed. It passes out, it says the test failed with, and this is the error code. And then the big thing is it exit 1. So the script exits with an error code of 1, and everybody knows that the script failed. If you don't, it keeps going. It prints out passed, and it exits with an error code of 0. So that's the big thing. Now, if we go back to our example, we have a script here. Kata. So there's a script here. Right here. If you just double click on it, it'll run. So we want to just edit it. And you can see it's the same script. And then to call that script. So you might call a script because you have, say you wrote something and say you've got 3 or 4 different VIs that you want to call. You might have a script that calls those 3 or 4 VIs in the right order, right? So maybe one builds your exe, one builds your installer, one does something else. So you might want to call them in a certain order. And rather than entering those commands all one at a time, you might write a script that does them all in the same order every time. And so here I'm going to run it, and it's basically going to do the same thing that it did before, except now I'm added the little thing at the bottom that says it passed and gives you the total time. So I calculate the total time inside the VI from the time I start the VI until I exit the VI. But I also calculate it from the time I start the script until the time I end the script, because that accounts for all the time that it takes to start LabVIEW and load everything. So that's why those 2 times are different. Questions? And that bash script is like super complicated. The bash script could literally just be, you know, the line that says GCLI and the name of your VI and whatever parameters you want to pass. So you would actually need the first line to tell it it's a bash script, but that's it. You don't need all the rest of that. That's just me getting a little fancy. Let's go back to the slides. I think I have a few more slides. All right, so now that we've gotten to the point where we've been able to write a VI to run the tests, we're able to call it from the GCLI, right? So we can call it from the command line, and we can use it as part of a script. So we can run multiple things via GCLI in a specific order, and we can do some other stuff, fancy stuff, move files around and do other things that we can do in Bash. And by the way, you can write these scripts in PowerShell too. So if you know PowerShell, you can do all this in PowerShell. I'm just not a PowerShell guy. I know more about Linux, so I use it in Bash. And you could probably even do it in command, the old batch files if you really wanted to. All right, so those of you who've used SVN, which is probably anybody who's been doing this for probably more than 10 years probably remembers SVN. In SVN, you had hooks, right? And they were hooks that ran on the server side, right? So if you remember, SVN had a completely different model from Git, right? There was one repository that resided on the server, and you checked out a working copy and you did stuff to it, but you didn't have a repository. You just had a working copy, and you could push and pull changes from the main repository. In Git, everybody gets their own copy of the repository. So you have your own local copy of the repository, and you push and pull changes to your local copy, and then at some point you sync up with the server. That becomes important when we talk about hooks, because hooks reside in your local repository. So if you clone a repository, the hooks don't come with it. They're just local. And you can see there's a whole bunch of stuff there. So you can do stuff pre or post committing, pre or post merging, before you push, before you rebase. There's a whole bunch of actions that you can take. And everything is stored inside your project. So Yahtzee Kata is a project directory. And inside that, there's a .git directory. And for those of you who don't know a lot about Git, that's where everything resides. So that's basically your entire local repository. And inside there's a hooks folder. And it's got a bunch of sample ones, and they all end in .sample. If you want to run it, you can just remove the .sample, and then when Git does the action, it looks in this directory, and if it sees something with that name, it runs it. And that's basically how it works. And I want to say, they could be shell scripts, they could be, Python scripts, it could be whatever you want, anything that can be executed. I don't know if you could put an exe in there, but you could try it. Anyway, so this is just a really simple example that comes with it. And it's checking some things and then outputs it. So there's a problem though, right? In that if you want everybody on your team to use a hook, right? Like say you write a hook, like one I used to write in SVN was to make sure that the commit message isn't blank, right? Because SVN would let you create a commit with no commit message, right? Which is kind of pointless because nobody has any clue what you did. Not that saying, change some VIs is any better, but at least it's something. So you would write the hook and it would reject the commit if it had no commit message. Well, you can do that. There's a pre-commit hook here. And you could look at the commit message in it and say, hey, if the commit message is empty or if it doesn't meet our standards, so maybe you have a standard where every commit message has to reference some Jira ticket or something, or some issue tracker thing, you could do that. And so you'd write that. So we can take what we have, the existing pre-commit hook that we had, and we can copy it into this folder and rename it, and that will enable that hook. And so that's what we've done here. So we have the pre-commit hook is stored as a file in the repository. And then we have a setup hooks.shell script that then moves that file into the directory. So this is, right, so bin bash tells it it's a bash script, setting the error handling. And then one command, it just says copy this pre-commit hooks.sh, throw it into the .git/hooks directory and call it pre-commit. So it's going to take that, rename it, store it there. Right? And then we run that script. And then once we do that, then we have it all set up. So let's do so So we run that. Cool, it added it. Now, if I make a commit, let's see, what have I modified? Okay, cool. So I modified the test. I think I probably just did something inaccurate to it. So let's do a git commit -am some commit should pass, right? So we're going to make a commit, and it should launch LabVIEW and run our tests. And it all passed, and everybody's happy, right? And let's prove to you that it actually works. If we make something that fails, here we're adding everything. Let's change this to a minus, right? This should definitely fail if we do that. And we'll save this. And let's just say we forgot to run our test, right? And we're going to make a commit. So we'll make it so now it's running our test. Oh, it failed, and it stopped, and we got an error or failed. Test failed with error 127. So now we know that our test failed. And we don't have to remember to click the button. We don't have to remember to run it. It's just going to automatically run it every time we commit. Now, the next thing you might be thinking is, well, maybe there's some weird situation where for whatever reason, I want to commit even though my tests don't pass. So in VI Tester, there's a way to make a test, skip a test. I highly recommend you do that instead and just skip that test. And at least then it's marked as skipped, and you know that, and all your tests pass and all your other tests pass and everything's good. But if you want to skip it, you can do git commit --no-verify, and that will skip the verification step. So it'll skip the running the tests. Oops. Oh, I forgot the.
So just to confirm, in the example, if you don't use the no verify, if anything but 0 is returned, then the commit just won't go through.
Yep, it just fails.
Okay.
Yep. Yeah. So
Okay.
here you can see that it. If I do that and look at the graph, you can see that where I said skip tests, it skipped the test and it made a commit anyway.
Okay, and it didn't have the should fail. Yes. Okay.
Yep. Let's just undo all that. Oops. I need an extra space. All right, so we just threw all those things away. Let's exit LabVIEW just to be sure and not save anything. Cool. All right. Anybody else have any other questions? So the hooks, right? They're only in your local repository. So in order to distribute them to other people, you take the script, you put it inside your repository, and then you just have one script that everybody runs as soon as they check out the repository or clone it. That then they run that, and it puts the hooks in the right place, and then everything works. So that is one thing. Like if you come from a place that's like very tight as far as like we want to make sure everything happens the right way, and like SVN is much better for managing permissions and stuff, and like it's kind of like the Wild West. So you can't force people to run the script as soon as they check it out. So you're kind of relying on people to do these things. All right. And I think we just did this, so that's good. All right, so now let's talk about what most people think about CI, which is GitLab CI. All right, so everything that we did was just the building blocks to get us up to the point where now we can talk about GitLab and Jenkins and those type of things. And if you're not using GitLab or Jenkins, like just what I showed you already could be very useful, right? So you can get a lot of mileage out of just setting up Git hooks and running tests and builds before you commit, or maybe before you push to the server or something like that. So, don't feel like you have to go jump into all this GitLab and Jenkins stuff right away. Because a lot of times, people talk about it and they show you this really complicated pipeline, and it works really well, but like setting it up, there's a lot of moving parts and it's kind of crazy. So I'm going to try to simplify it a little bit and see if you guys can follow along. But so when we're talking about GitLab CI, like the big picture is you basically have 3 computers. You have your development machine, which has LabVIEW on it, and that's where you're editing your code, right? And these could be virtual machines or physical machines, doesn't really matter. So you've got a machine where you're editing LabVIEW code. And then at some point, you're using Git to keep track of all your changes. At some point, you push it to a server, right, to act as a backup or to allow you to collaborate with other people, right? So in this case, it's a GitLab server. And it could be on the GitLab.com cloud servers. It could be inside your network. They have self-hosted options, right? And so that GitLab server has a Git repository. And so you can push and pull stuff. You don't ever have to do any of the CI stuff. You can just use it as a repository to hold all your code. But GitLab also has this CI function. And so you create this YAML file, YML file, and it's a set of instructions. And so when you push code to your repository, Git checks to see if this YML file exists. And if it does, it interprets those instructions and goes and does stuff. But the server itself doesn't actually do the work. You have these build, test, or deploy machines, depending on what you're using them for, right? And they run this thing called GitLab Runner. So you have this third machine that runs GitLab Runner, and it communicates with the GitLab CI server. So when you create this machine, you install GitLab Runner, you do a register step where you point it at the server and give it some credentials so it can talk back and forth. And then this runner is just sitting there waiting for jobs. And so you check something in to your local machine, you create a commit, you push it, the GitLab server sees this YML file, pulls out all the commands, and sends them to the appropriate build, test, deploy machine, right? And that GitLab runner on that machine gets that job, and then it pulls down the latest version of the code through Git, and then it does whatever the command tells it to do, right? So it executes a CLI script that can call LabVIEW right through the GCLI. It can also do other things, like it could copy files, move files, it could send an email, it could throw stuff on a web server, it could do all kinds of stuff, right? And so generally you have these 3 machines. And you might have multiple runner machines. So you might have one that you use to do all your building, one that's like a test system that actually maybe has hardware hooked up, right? You might have something else that's like your deployment. And the other thing you'll see a lot when you talk about CI stuff is people talk about pipelines and stages and jobs. And so basically a pipeline is what happens from the time you push your code until it's done. That's like the whole thing. And then there's a series of stages that execute in series, right? So the test stage executes before the build stage, which then executes before the deploy stage, right? And the thought process here is that if you run your test first, it fails the tests, don't waste your time building it because it doesn't work, right? And if it fails building, don't bother like uploading it or publishing a package or something because it didn't build correctly. And inside each stage, then you could have jobs that run in parallel. So your testing stage, you might run VI Analyzer and unit testing in parallel. In your build stage, you might build multiple things and you could build them in parallel depending on what you want to do. So, and then there's a way to pass files from one stage to the other. So for example, when you build an executable on an installer. Then in the deploy stage, it's not only going to get the code from the Git repository, it's also going to get the results of that build, so that then it can package them up into a zip file and upload them to an FTP or do something like that. Questions so far? Okay. So the file that you need to create in order to set all this up. So when you're setting this up, there's really 2 steps to setting up CI stuff with GitLab. Okay, if you're using Jenkins, it's a slightly different paradigm in that Jenkins doesn't run on your CI server; it runs on its separate server, and it needs access to your Git server, and there's a whole bunch more setup. GitLab's by far the easier one to set up. So to set it up, you need to set up your build, test, deploy machine, and install everything you need on there, LabVIEW, whatever else, other tools you need. You need to install the GitLab runner and register it. Then that's ready to go. And then on your dev machine, all you have to do is create this YML file that lists all the jobs. And you have to add a tag that tells it to use this specific runner. And we'll show you how to do that in a second. So this is the simplest thing that you could possibly do to set up CI as far as creating this file. So you create a file called .gitlab-ci.yml, and you put that in your root directory of your project. And this first line here where it says hello world, that's the name of the job. So that can be anything you want. It's just an identifier. Then you have a tag section. You have to list the tags. In this case, I have LabVIEW 2020 X32. So when I created my runner and registered it, I gave it this tag. So now this tag is what tells GitLab to run this job on this particular machine, right? So you could have, a machine with LabVIEW 2021 X32. You could tag that. You could have a machine with test stand. You could tag it as having test stand or having real time or FPGA or however you want to do that. And then the next section is you have a section called script. And here all we're doing is we're calling GCLI with the echo command, and we're echoing hello world. And so if you drop that in your repository and you had a runner that had LabVIEW, was tagged with LabVIEW 2020 X32, it would run, right? When you checked it in and pushed it up to the server, your runner would kick on, it would load LabVIEW, echo hello world back to the CLI and exit, and the whole thing would pass and everything would be good. And you can add other jobs. You can have multiple jobs. You can have stages. So if you don't define any stages, it just assumes there's one stage called test, and it throws all the jobs in that stage. So here I'm not specifying any stages or what jobs go in what stage. Now, installing GitLab Runner. So if you go look up how to install GitLab Runner on Windows, you come to a page that looks like this one on the right. Basically, you create a folder, you download this executable, you drop it in there with a certain name. Then you open an elevated command prompt, you run a command called like GitLab runner register. It asks you for some information. So it asks you for what server it points to, whether it's gitlab.com or some internal server that you have. And then it asks you for a key, and it'll ask you a couple other questions. It'll ask you for tags, so you can enter the tags. And then it'll ask you for an executor. And so for these, you just want to be a shell executor. So you type in shell, and that just runs shell commands. There are some other ones that you can look into. If you're going to do all this, once you do step 5, stop. Don't follow these things and run it as a service. It's a pain in the butt. You should check out my blog post. I have some things for what to do from here on. The problem is if you run it as a service, you can't watch what's going on, so you won't see things opening up. So you can't watch it open up LabVIEW, and if it gets stuck on a dialog or something, you won't know. And the other thing is if you run it, particularly if you run it as a built-in system account, the environment variables in the path are different from the user account. And so that will cause you all kinds of problems and headaches. So there's a way to just run it as a script like at startup. So you set it up so that your machine, every time it boots up, it auto logs in and it runs the script and it works just fine. And then you can actually see what's going on. I have a couple articles about this. If you're using Jenkins, Jim Kring wrote an article for JKI blog about how to do that with Jenkins. All right, so let's see. Where am I at? Cool. All right, so let's take a look at this. So I set up a second repository. Let me see, menu, projects, my projects. Here we go. Cool. All right, so let me make a change first, right? So let me gotta make a change in order to be able to push something. Let's see. Let's open the project. We'll make a simple change, and then we'll go through that process. So let's go here. Let's just make a purely cosmetic change. We'll rearrange the front panel and save it. All right, save, exit. So now we got a change. We'll make a change. We'll commit it as cosmetic change. And it's going to run our tests, which is fine because we already have that set up. So we can see here, here's where we already made this cosmetic change. And now we're going to push that, but not to the origin. We'll push it to CI. But before we do that, let's take a quick look. I added this GitLab CI.yml file. Again, this is the simplest thing you could possibly do. Right, we could do more because we already have everything set up to run the test, but we're just going to echo hello world just to show you how it works. So now I'm going to git push to the CI remote repository. And actually, let me make sure I have this open. So I got that here. Oops, why won't that just go? I just want to dock on that half of the screen. Can I not do that? All right, come on, Windows. There we go, done. Cool. So here's my repository. Notice this green check mark here. This means that the last time I ran my CI, the pipeline passed. So, but I'll do this. And now you can see it's sending it up there. If I refresh this, now you see this is pending. So if I click on this, I can see the pipeline as it's about to run. If I click here, I can see all right, hold on. That is enabled, so why is it not? All right, well, normally that would start running. I'm not sure why that's not running right now. Why does GitLab think I don't have anything assigned to it? Oh, let me make sure my runner is actually running. So when you set up a runner, you definitely want to be able to remote desktop into it. Oh, and it's not running. Where is it? There we go. Now it's running. Cool. Oops. Let me dock this. All right, I got too many things docked up here. How do I get out of the remote desktop? All right, now I'm in hell here. How do I get out?
You can minimize the remote desktop, that bar right at the top with the IP address. You can minimize the remote desktop window.
I don't see that though. It's hidden. Oh, there it is. Okay, it was hidden behind my stop presenting. Okay, cool. So I don't know if you noticed, but while we were watching there, that actually popped up, and it and the echo thing popped up, and it ran. And if we go here, back here. So if I click on this now, it says it passed. And I can open this up and I can see the output. So a lot of this output is stuff that GitLab is doing. But if you go down here to line 15, where it says executing step script stage of the job script, this is your script that's running from there. So this GCLI echo hello world, this is the script that I put in. Here's the response in white. And then it's just doing some cleanup and it returns and says it's succeeded. And we could replace that GCLI echo hello world with running our tests. So actually, let's do that, because that's pretty easy to do. So if we just edit this, and instead of echo hello world, we can call GCLI /test.py. And we can save that. Cool. And now we git commit test to CI. And it's running them again locally. I could have skipped it if I wanted to. And now if I go back to this remote desktop, you'll actually see open up and run, hopefully. Might take a second or two. Yeah, it looks like it just received it. So yeah, it's going to work. It's opening LabVIEW, running the tests. And here it says job succeeded. This is the output from the GitLab runner program itself. All right. Cool. I think that. All right. So that was a lot of it. There is another thing, and that is artifacts. So what you can do, here I have a couple jobs. So I have a CI job for stages. We didn't talk about stages, but basically at the very beginning of your file, you list all the stages, and then when you have a job, you tell it what stage it's in. So this CI job is in the quick stage. It's running on a machine that's tagged prime test. The script it's running is a bash script, so it's running ci.sh. And inside there, it's doing a whole bunch of things. It's running a bunch of tests and building a bunch of stuff. And then the next section, artifacts. That's an interesting section. So artifacts lets you grab files that you build. So it lets you grab reports. It lets you grab results of tests. It lets you grab packages that you build or executables and stuff, and store them on the GitLab server so that anybody can go look at them. So you declare that you have some artifacts. You give it a list of paths. In this case, they're folders. So if they're folders, they just get zipped up. If it's an actual file, it'll grab the file. But then the one key thing I wanted to say is often you want this when always there, because if the job fails, it won't grab the artifacts. Which if it's a build or if it's an executable or something, okay, fine, don't grab the executable because it didn't build. But if you turn on the build log, you might want that. So what I do is I turn on the build logs and then I grab the artifacts always. And if my build fails, then I have the build log that tells me how it failed. And I have an example of that. So that I think you'll find very useful. Control click. What? There we go. Cool. So this is a project that I was doing for somebody. And you can see this is the output of my script. So I'm running the ci.sh script. It's got a whole bunch of steps. Closes LabVIEW, clears the compiled cache, applies a VIPC file, runs anti-doc, which is a tool for generating some documentation, runs VI tester, that passes, everything's good, starts the build, and it says failed. Build failed with error 1. Right? And the other thing about GitLab is if it fails, you'll get an email about it. So if it fails, you get an email about it. One important thing that I missed too, when you push to GitLab, if you make 4 or 5 commits locally and then push, it only runs the CI on the most recent one. So instead of running it 5 times, it just runs it once on the most recent. So that's important to know too. But anyway, so this failed and I got an email. Yes? Question?
Yeah, so in the chat, Chris asked if the 3 machines are all Windows machines. So you've got your dev machine, you've got your runner machine, and then the Git and CI.
Yeah, so the GitLab CI server is Linux because it won't run on Windows. But the other two can be anything. So you can get GitLab Runner to run on Linux or anything. So now you have to get LabVIEW to run on that platform. But yeah, you could do everything in Linux, and that's fine too. Does that make sense? Hopefully that answers this question.
And then a question of my own. Did I hear you say that, and obviously for many of our customers this is an option, but did I hear you say that you have the option to have Git host both your repository and your CI?
Yes, so you can, so right now the repository and everything runs on their thing. You can self-host that, so you can run that inside your own network if that's where your question is going. Or are you talking about hosting the runners as well?
Well, I was talking about the repository and the CI tool. I'm assuming the runner would be your local machine.
Yeah,
Although,
yes. So yeah, the GitLab.com hosts everything. So you can do everything I'm doing is through GitLab.com, and they have a free plan that lets you do a ton. Everything I just did was the free plan. But if you care about privacy and security and you like, I don't want it out there, you can do it inside your own network. Now, even on GitLab.com, they have private repositories. So unless you're like a Mil-Aero thing where you've got like really stringent security policies, you should be fine just using GitLab.com. So if there are any more questions, please feel free to interrupt. But on the right here, you see it says job artifacts. So I can browse those. And I can go into my build directory. And I have this log file. And it's not going to let me view it. It makes me download it. But I can search for error. And why did it not find it? There it is, error. Right? So I just immediately search for error, and I see 1502 of VI broke during the build process. And I know exactly which VI to go look at now. I didn't have to open up LabVIEW. I didn't have to do anything. I got an email saying, hey, your build failed. I clicked on the link. It took me to that page. I clicked on artifacts. I scrolled through the thing. I saw that the build failed. Clicked on artifacts, looked at the build log, and now I know exactly what's wrong. So I think that saves you a ton of time. Right? So,
yeah.
And I don't have to wait around for the build either, right? So if your build takes a long time, you make a change, you push it off to the server, and you go about your business. And if something's wrong, you'll pop up an email, and and hopefully it doesn't take too long. But so that's a really valuable, useful thing to do. So that's basically the end of my presentation. So I don't know if any people have questions.
Yeah. What is your what is your setup in your office? You said you're running the Git and CLI off of their, or Git and CI off of their servers. Do you actually have a separate physical computer for your runners?
Yeah, so I have a workstation. It's like a single core Xeon with a bunch of RAM, and I have a whole bunch of virtual machines on there, and I use the virtual machines for the runners.
Okay.
So typically when I start a new project, I will set up a machine for that project. So I'll install the correct version of LabVIEW. I'll install test stand, RT, whatever I need. And I'll install whatever like third-party drivers. And once I have it all set up, I'll just copy that machine and throw it on the server and rename it as the runner. And then I'll just go install GitLab Runner and register it, and it's ready to go. And then I don't have to install all that stuff twice because that's just a pain in the butt.
So you're just using clones of your dev machine VMs. Okay, no, that's slick. I like that.
Yep. Yeah, I mean it works well. I mean you can try and do just one machine per LabVIEW version, and if you don't have a bunch of third-party drivers, that could work well. Because like one of the steps that I have is like I always apply a VIPC file at the beginning. So,
right, so and that, your current setup.
Yeah, and that takes time. But if you run a bunch of jobs in a row on the same machine, on the same project, then it's not, the VIPC file is smart enough to know that it doesn't need to apply it. So it just checks it and says, oh, it's good. And that only takes like a second or two.
Okay.
So there are probably some other questions, and I'm curious to get input on this, but like I tend to have like a CI script for for like a portion of it so that I can run it locally, right? So the one I showed had a .ci/.sh script or whatever. So at any point in time, I can just run it locally if I want to do the build locally, or if maybe I'm still on a customer site and I don't have access to the internet, but I still want to run everything, all the same stuff that I would run on my CI server. I can run it locally. I don't know how people feel about that, or I haven't quite figured out what the best way is between the script in the YAML file and writing out a whole bunch of steps, or putting them all in one script and then being able to run it locally. I don't know if there's a big difference or not, but that's just something that I'm like toying with and trying to figure out the best way to do.
Hey, Sam, I got a somewhat unrelated question to that.
Yeah.
If you have projects that so you kind of mentioned your workflow is you'll set up kind of a new VM per project. What happens, or maybe this doesn't happen for you, when you kind of put a project down for 6 months, a year, or whatever? Or does that take a while? Is that something like, do you have a process for how to set runners back up?
Yeah, so probably if I knew like the project ended, like the purchase order ended, and I knew they weren't going to renew it, right? Then I just take their VMs and I just put them on a share drive somewhere, or on a NAS or something, and just store them there. And then whenever they start up again, I can just pull that out of the storage drive and just spin them up. And that seems to work.
Okay.
Because there's no sense in running it there's no sense in running a runner for a job if I know I'm never going to use that, if I know I'm not going to do anything for that in the near future.
Yeah, I just know the setup and maintenance can sometimes be annoying.
Yeah. There is a problem with VMs, particularly with Windows 10, in that if you haven't run a VM in a while and you boot it up, the first thing it does is spend an entire day doing Windows updates.
Nice.
But other than that, yeah, it's a huge pain.
Yeah, it's pretty gross.
Yeah.
It's pretty gross.
Which is why we should all use Linux, but that's a whole other discussion.
Yeah, and those run a bunch of updates if you're bandwidth challenged, like I am in my current location.
Yeah.
You fire up your VM, and then it hogs all your bandwidth, pulling down the updates, and then continues to hog your bandwidth until you complete the update. It is the weirdest damn thing. Yeah, we've noticed this in the house.
There is a setting in Windows that you should look into that lets you pull updates not from Microsoft, but from other computers on your local network. So that might save you some bandwidth, because if your wife's computer is also on the same network and it's updated recently, it can just pull them off of that or something. So
yeah, I don't think we have enough computers in the house for that to be useful.
Yeah.
And I'm also hoping that I'll get, I'm on the wait list for Starlink. Hopefully that'll happen, sometime in Q1, and my life will get better.
Oh.
There's a question in the comments from Enrique. Do you recommend this for all projects or only the long-term ones, and how much time you need to make a setup?
I think it's something that any project can benefit from. If you have a small project, it's probably not worth setting it up just for that small project, right? So like there is a setup and learning time curve, but you go over that learning curve once. And like for me to set up a new runner, I did a video, I think I sent you a link, Alan, with Casey. I walked him through it, and we took our time, and it took me an hour, but I could probably do it in 20 minutes or half hour to set up a new runner. Just to set up
that video.
Just to set up the GitLab runner, I still have to install LabVIEW and do the Windows updates, and so it's a little bit more involved than that. But I mean, in one day, I can have it set up for the project.
Okay, all right. So that's that, and that is, of course, I would imagine billable to the customer because you're setting up their infrastructure.
Yeah, exactly. Yeah, I totally do feel that.
Service.
Yeah, and honestly, from their point of view, it actually helps them, because once you have it set up and you get that quick feedback, you can move way faster, and you can go and do things, and you don't have to worry about breaking things, because you'll know instantly if you broke it. So I find it helps all way faster.
The only part of this that I'm actively doing in my projects is test-driven development and unit testing, and just the savings on that is spectacular. And I'm doing, I kick off my tests manually, just in the VI tester interactive window. So they even take a little bit longer to run, and even that savings is just staggering in terms of what it does for project efficiency and for reducing the amount of post installation debugging that I have to do.
Yep.
Even just that much, it's at the point where if we put it on the project I'm thinking of, if we put it on the machine and put the machine in the field and there's a bug, it wasn't 9 times out of 10, maybe even 19 times out of 20, it's not my code. They didn't tell me something.
Yeah. Well, I was going to say most bugs are not code related. Most of them are communication related, but I mean, there are some code related ones. Like I meant to put it in the true case and I put it in the false case, but
your unit tests catch most of that crap.
Yeah, exactly. That's what the unit tests are there to catch. If the requirements are wrong, like the unit tests don't help you, but
yeah, almost all of my, every now and again, there were things, there were a few issues that were just, buried in the code somewhere that we didn't unit test for. But, almost always it's like, oh, the machine doesn't do what we expect it to do, what the machine designers planned for it to do. There's some mechanical issue that now we have to account for, or some other parameters were not correct, and things you can't really track in unit tests. So these kinds of setups are definitely worth it.
To me, the biggest change has been just not debugging. So much of debugging is just chasing down where the problem is. Usually the fixing it part is easy. It's just the tracking it down. So if you can say like, hey, I know everything's good except for this most recent commit, it's really easy to just throw it away and start over. Particularly like if you are committing often, so you've got small commits. If it's 5 minutes of work, I'm not going to spend a half an hour, 45 minutes trying to debug something to save 5 minutes of work. It's like after 5 minutes, I'm like, okay, I'll just go and start over. So,
right.
Yeah. And those add up pretty quickly. So, and the other point I wanted people to take from this, and hopefully y'all got that, is that, by the end, I was showing you some pretty complicated stuff, but it's all just built on these little building blocks, and you can start doing any of the building blocks right now. I mean, you can start as simple as just start writing unit tests for your next project, or, figuring out a way to automate your build, right? And then as you do these things, just like what I'm doing right now in one project I'm working on, I took it over and I'm adding all this infrastructure to it. But every sprint, I'm doing one super simple little thing that they can see that's visible. And then I'm spending the rest of my time building up this infrastructure.
Yeah.
So I show them I'm delivering something, but I'm building up this infrastructure. And I even told them and made it clear to them what I'm doing. I'm like, we're investing. And then once all this is up and running and ready, things are going to go so much faster. And it's going to be very easy to add stuff. So
it would be great, Sam, if there was a, here is your roadmap.
Yep.
Here's the chunk you can do today.
Yep.
Here's the chunk you can do next week. Because I know one of my problems with this is, it is a lot, and it is intimidating, and we have things that we need to get done. And what are the chunks? What are the useful pieces we can get? Just going and looking at the command line interface and starting to play with that. That's an easy step. That's something that I could do tomorrow. Well, not tomorrow because I have to teach, but but you get the idea. So you have a workshop.
Yeah, actually,
you have planned for right after. Well, you have one before, which is going to be at TQMH, but you had one after that was going to be on CLI stuff. How much CLI stuff? How much of what you've just shown us are you covering in more detail in that workshop?
It's pretty much this whole thing. So this is like the broad outline of what I want to go over, and we're going to go into more detail on how to do all that. And a lot of it's practice too. So like the Yahtzee kata thing, we're going to go through the whole entire kata, and you're going to like practice the refactorings and everything in there as well.
Okay.
If anybody's interested in that, you should definitely sign up. And if you're going to sign up, you should let me know now, because as of right now, there's not enough people to make that class go. So if you liked what you saw here, you can come and practice. And it's one thing to sit here and watch me do it really quickly. And okay, that looks cool. But until you actually do it yourself, there's a lot of little gotchas and little things that you got to think about. And so it is challenging because there's a lot of moving parts. But you know, it like Alan said, it's about biting off small little chunks and doing little things to just kind of start chipping away at it. And it's amazing. Like you chip away at it like a little bit, you know, every week or whatever for like a year, and all of a sudden you've like made tons of progress. So yeah.
Yeah.
I'm wondering if you can speak to using different types of Git servers like GitHub or something like that. Have you done that, or is the reason you chose GitLab, is it easier to use for this type of thing?
Yeah, so that's exactly why I chose GitLab. Part of the reason why I chose GitLab in the beginning actually was because GitHub, originally you had to pay to have private repositories. Now I think they give them to you for free. But GitLab had unlimited private repositories. So that's why I started using it. And then when I figured out that the CI stuff was so much easier, because like the problem with Jenkins is Jenkins runs as a separate server from your, so you got GitHub and you got Jenkins. You got two servers to manage and they have to talk to each other. So that's a problem in the admin setup right there. And then also Jenkins uses some sort of like Java or something, Groovy or something to write scripts. And I just found that the GitLab YAML was just really simple and quick and easy. And setting up the runners is pretty easy once you've done it once or twice. I mean, the first time through, you definitely read those instructions really carefully. But after you've done it 2 or 3 times, you're like, oh yeah, I know exactly what's going on. I mean, I still reference the instructions so I get everything in the right order, but it's, like I said, I can do it in 15, 20 minutes and it's pretty easy.
Yeah, it adds up to a lot of complexity, though. I mean, it's worth pointing out that you know, there are a lot of organizations, not even necessarily large organizations, but you know, even mid-sized ones, where you know, DevOps is a job. That there's a person who that's what they do. They don't develop code. They just keep all this stuff running, and it's
yeah. Well, debugging this stuff can be a big problem. So you noticed I had remote desktop open that I could access the server and see what's going on.
Yeah.
And also the way you set it up, like I said, you don't want to run it as a service. You want to run it as your user. And there's some blog posts, and I can repost those links or something if somebody didn't catch them. But it walks it through pretty good. I made sure I wrote it down, and then I followed those directions when I set up the last one. So I know they're pretty good, and they definitely work.
We record these obviously, and they get posted. I think Craig handles that because I as I was going through this, I was taking notes, and I'm like, no, this is recorded. I think I'm just gonna go look at the recording later. Craig, how long does it take to get these up, and where do they end up?
Typically they're posted in the same NI forum.
Okay.
I think we're missing the last few. I think Fabiola was the one that was making sure that all happened.
Oops.
So these have been recorded still, but I don't think we've done a good job posting them. But this one is being recorded now, so.
Yeah. Well, if we can make sure this one gets up, and then we can maybe track down the other ones. But there's a lot of little fiddly bits here that are that are definitely worth going back to the video on.
Yeah, and just to like whet people's appetites for what more is possible beyond this, I've been working on deployments. So I've got it now to where when I want to create a release, I just create a tag in Git and I push the tag, and GitLab automatically creates a release. So GitLab has like a releases section, and it has a package repository. So you can put your build executables and stuff in their package repository and then set up links to them and then email it to your customers. And what I want to do is have my project, like the built code, look at that package repository and determine that, hey, there's a new version, and then automatically download it. So like imagine if your customer asks you for a change, you go into the lab code, you make the change, you save it, you tag it, you hit commit, and walk away. And it builds everything. If there's tests it and builds it. If there's a problem, it lets you know. If not, your customer, the next time they start your program up, it says, hey, there's a new version available, and they just click download. Like, how much time would that save you?
Well, that was the old. That was the vision of the old deploy system, but it was too much internal proprietary stuff, and
But it's totally possible with GitLab right now. I mean, I'm very close to almost having that done. on this project that I'm working on, I will probably get that done in the next like month or so. So, and then once you do it for one project, you basically just copy and paste it and adapt it a little bit, and you can run it on other projects. I mean, those are the things where, like, you know, taking the time to set it up is a lot, but once you set it up, you can copy and paste that, and you can run on some little dinky project. You could set that up in, you know, 10 or 15 minutes and have it up there, and that's like a huge bonus.
Right, but you just have to figure out a way to, you know, if you're running a small shop like I am, you need to, you know, have that customer that'll pay for the learning curve and the setup for the first time.
Yep. You could also hire somebody like me. So
that is very much the back of my mind. I think, Sam, if I get a call to set one of these up at this point, it's you're getting a phone call.
I would very much appreciate that. But yeah. So. Any more questions?
All right. Well, I think that's a wrap. If there are no more questions for Sam, thanks for taking the time to do this and setting up the presentation. Do go look at you know, GDevCon North America, guys. When's the last time we got together in person? You know, come on out and meet us all in Boulder. And then look at Sam's workshop the day after.
Thank you for inviting me, Alan. It was fun.
You're most welcome. We've got another comment coming in. Another thanks, because you're awesome. And we'll get the, you know, watch our forums. We'll get we'll get this recording posted. We'll figure out how to do that.
Yeah, and if you've got questions, you can find me on LinkedIn and Twitter or the NI forums or something. So
yeah,
I'm around.
Oh, and shameless plug, I don't know what our next meeting is going to be, but I think it's going to be sometime after Thanksgiving, but before Christmas. That's about the 3-month mark. We still have to set a date, but do be thinking about what you want to see. If any of you want to share our space and present, we're taking suggestions. There is a pinned forum post for suggestions and kudos for things we want to hear about. We'll try to get our next date picked out soon, so we can hopefully get commitments from folks.
I have one more thing, Alan, too. Somehow I also got roped into helping with the GCLA summit. So those guys would be really upset if I didn't try to plug it here. So the GCLA summit, because you mentioned Thanksgiving, it's like a week or two before Thanksgiving.
Like the 15th.
24-hour virtual summit. They're looking for presenters. They've got a bunch already, but if you got something to say, they'll be glad to have you.
Oh yeah, I'm
make sure
presenting at that too. Apparently, I'm a glutton for punishment.
Yeah, me too. So,
all right. Well, thank you all for coming, and we'll hopefully see you next time. If anybody feels like chatting, now is the time to do it. Otherwise, you know, you don't have to go home, but you can't stay here.
I will